Load cells are used across many industries where accurate weight and force measurement is important. They support manufacturing and automation for material flow and batching, food and beverage for precise filling and packaging, and pharmaceuticals and chemicals for accurate dosing. They are also used in automotive and transport for vehicle weighing, construction for monitoring structural loads, aerospace and defense for component testing. A load cell is a sensor that converts weight or force into an electrical signal. It uses 4 strain gauges connected in a Wheatstone bridge. When no load is applied, the system is balanced, and the output is nearly zero. When a load is applied, the strain gauges slightly deform, changing their resistance. This unbalances the bridge, and generates a voltage proportional to the applied weight. Selec offers a 24-bit load cell solution, in the MiBRX and Flexi series, delivering high accuracy, selectable gain settings, and configurable 5V or 9V excitation via jumper selection. This video demonstrates the configuration process using the MiBRX 4M. The load cell card is designed to slide into the PLC slot, and lock securely with a gentle press. The sensor excitation wires are connected to the respective excitation positive and negative terminals, while the sensor signal outputs are connected to the S0 positive and S0 negative terminals. When connecting a second sensor, loop the excitation positive wires of both sensors, and connect them to the excitation positive terminal. Similarly, loop the excitation negative wires, and connect them to the excitation negative terminal. The feedback signal from the second sensor should then be connected to the S1 positive and S1 negative terminals. To begin, open Selpro, and navigate to the Settings menu. From there, go to Project Settings, then click on Card Selection. In Card 1, select Special Function, and choose MiBRX-SC-LC02 from the list. Next, open the Edit Wizard. Under the Analog category, you will find the Load Cell Average block. Click on it to insert the Load Cell Average block into your project. Just above that, you will see the LC Calb block. Click to add this Load Cell Calibration block to your project. Within the Load Cell block, the EN input is used to enable the operation. When EN is on, the Load Cell block becomes active. The CS input stands for conversion speed. When CS is 0, off, the conversion time is 100 milliseconds. When CS is 1, on, it's reduced to 12.5 milliseconds. This setting lets you select between standard and high-speed conversion, depending on your application requirements. Finally, the TT input is used for the tare or zero function, which resets the reference point of your measurement when required. SN, slot number, defines the slot where the pad or module is connected. Channel number, specifies which channel we want to calibrate. AVG, is total number of samples required to be taken for averaging. ERR is sensor error condition. PW is gives current process value or present weight. Here, we are using a calibration block which consists of the following parameters. When EN is on, the load cell calibration block becomes active. SN, slot number defines the slot where the pad or module is connected. We are selecting slot number 1. Channel number, specifies which channel we want to calibrate. And we are selecting channel number 1. CD is for calibration code, 0 is for no load or 0 calibration, 1 is for maximum weight calibration. SPWT, span weight, the known weight value used to correct and match the actual display value. Connect calibration coil to ENO. Now, let's begin the calibration procedure. For 0 calibration, ensure no weight is placed on the load cell. Set calibration code, 0. Set span weight as 0. Trigger the enable bit. When calibration bit is on, then only known weight calibration is done. Next, we perform span calibration. Place a known weight, for example, 1 kg, on the load cell. Change calibration code as 1. Set span weight as 1000 in grams. Now, trigger the calibration again. When calibration bit is on, then only known weight calibration is done. Once the calibration is triggered, the calibration data gets stored in the PLC, the system will now display the correct calibrated weight value.